Good morning. My name is Conrad Countess. My initials are CJC, and I am an independent researcher. I deal in physics. And I'm going to call this episode CJC versus the LHC. And as I said, CJC stands for, or my initials stand for my name, Conrad James Countess, and the LHC stands for the Large Hadron Collider, which is a gigantic particle accelerator in Geneva on the border of Switzerland and from Geneva to Switzerland on the border of France, Swiss border. It cost $10 billion, I'm told, and is manned and woman by thousands of physicists from around the world. They have a computer network that's connected to computers all over the world so that they can process all this data that comes in. And as of July the 4th, 2012, they claim to have found the Higgs boson, which is a boson that they've been in search for since 1965, I think, when this guy named Peter Higgs suggested it in a paper. And it was, of course, a couple of other guys who suggested also that there should be a boson that helps impart mass or energy. Let me see if I can get some more light in here. Okay, well, I'm here to tell you that the Higgs boson is an unnecessary complication. The Higgs field is just a rehashing of the old ether field. The old ether field was a field that they imagined to exist from the ancient times. The ancient people intuitively felt that space was not absolutely empty and that it was a void from and within which everything arose, had its being, and went back into. And as it turned out, scientists found out as time went on that matter does come from the energy of space and then it dissolves back into it. Now, you have different versions of it. Some people say that we came from a point expanding in space and they call it a Big Bang coming from nothing. Lawrence Krauss, he's a famous physicist and popularizer of physics. He's on a lot of different shows and he has a lot of webcasts. He says that it's not absolutely nothing and he's right, but he calls it nothing. It's quotation nothing. And it's an energy in space and the universe materialized out of it and is expanding into it. And I give him credit for explaining that because at first he just said that it came from nothing. Everybody was saying it. Not everybody, but a lot of people were saying it. It doesn't even make sense to kids, you know. But anyway, so this formlessness, which is the closest thing to nothingness, gives material form. Material formalizes out of it because there's no such thing as totally absolute nothingness. Empty space is full of energy, and matter is just a manifestation of the energy, a condensation of it. And that was known for years. Particle physics knows that elementary particles are but condensations of the field. Einstein admitted that general relativity was unthinkable without the ether, and that matter is the manifestation of the curvature of space-time. But before that, when he postulated his first theory of relativity, which was the special theory of relativity, he claimed that there was no ether because these guys by the name of Michelson and Morley and some other people, they tried to detect the ether by measuring it against the motion of the earth, and they could not tell that the earth was moving through anything. Like if you stuck your hand out the window and the air rushed by, you could tell it which direction you were moving. These people were trying to detect the ether wind. That's the analogy some of them use. And they could, you know. And so some people say, well, uh, things bend in the direction of motion. The merchandise is contracting in the direction of motion. Things get heavier in the direction of motion. Time slows down in the direction of motion. And it slows down and shrinks and all this stuff happens in direct proportion to the speed of light so that you'll always measure the speed of light to do the same. Okay. So instead of there being an ether that everything was moving through, they said that space and time just changed and the matter just changed. It contracted. It got heavier. Time slowed down and everything changed so that the speed of light could stay the same. And there was no ether. That didn't even make sense. But anyway, like I said, later on when Einstein came up with this general theory of relativity, he admitted that the general theory without the ether was unthinkable. And then later, particle physicists found out and they admitted that elementary particles such as electrons, photons, all elementary particles are but condensations or concentrations in the ether field. Well, anyway, you have a lot of people who still deny the ether and they wanted to replace it with something, so they figured that, you know, we'll just make something up and call it a Higgs field after this guy Higgs. Or he came up with something and some other guys came up with something because something had to be giving things mass. Something had to be creating drag on things as they move because things get heavier as they move. They get heavier in the direction of motion. Now, if you ride along in a car and you stick your hand out and you're going the same amount, same speed as the car, you stick your hand out and touch the front of the car, or reach out and give somebody a soda from your window to their window, you might not feel no extra weight of the car moving forward, and you can stick your hand out and touch the front of it, but you feel like you're not gonna feel anything. But if you were stopped and that car was riding by at that same time, you wouldn't be able to pass the soda back and forth, and you wouldn't be able to stick your hand out without a car would get knocked off. So people realize that the weight of things was depending on the motion of the observer and the observed, like the car and the person riding with the leader sitting there. But still, motion created weight, and it's not heavy. And the people who came up with the theory of relativity kind of like distorted it and made it very complicated. But we're not going to deal in all that complication. What I'm here to tell you is that, and I have some notes, I hope you don't mind me looking at these notes. Um, like I said, I call this part CJC versus the LHC. Now, some say that gone are the days when a lone researcher can make grand discoveries, that only teams of tenure, title, degree people working for years, 50 in this case because they came up with the Higgs theory in 1955, I think it was, and they just discovered it, or said they discovered it, July the 4th, 2012. Now, these people work across continents because they had people from all these different nations working together with a $10 billion machine. Now, I have to say, the engineers, electrical and electronic engineers who built this machine, they're the real heroes. They say this machine is the most complex machine in human history. They probably is. Now, to get that thing work took a lot of ingenuity, a lot of thinking, a lot of coordination. But screensaver. But I probably should fix it right now. I'll be right on top of it. But as I said, these villagers, they didn't use this thing right. They misinterpreted the data. They claimed that they found this large hadron uh, colliders, evidence to point to a Higgs boson, and I say that they're wrong. As a matter of fact, I say that the origin of mass is motion like it's always been through the ether field, which is also a gravity field, which is also electromagnetic field. The EM field stands for electromagnetic, and it also stands for energy matter field. Okay, so that's all you need. You don't need to invent anything else. Call it Higgs field. And the way they say it works is so doesn't even. If you listen to how they explain it, they say, well, it's like say that everything, all the particles will be moving at the speed of light. And since the Higgs field is there, it makes the things like, say, a photon, a light particle that moves at the speed of light. They claim that it has no mass, but it does. And I'm telling you, that's one reason why they threw themselves off saying that it doesn't have any mass. But it has mass. But they say that when this light particle travels through this Higgs field, it's like barbarian or something riding through tree cone and getting slowed down. And that's how a particle gets its mass. And it says that these Higgs particles exist at every 10 to the negative 17 centimeters. And the light particles bounce off of these particles every 10 to the 17, negative 17 centimeters. And that's about as big as the elementary particle with rest mass. And that's how it gets its rest mass, from bouncing off of this stuff. And that's how the Higgs field and particle turns light energy into rest mass particles such as electrons and quarks and stuff. But I say, wow, that's a very wrong, overcomplicated way to put it. If you just start knowing that light does have momentum and kinetic energy and relative mass already, we know that because of the photoelectric effect. Shorter wavelength light, like blue light, has more momentum than longer reddish colored light. And when people had bounced these light waves off of metals, they found out that the bluer, more particle-like light, because the shorter the wavelength, the more particle-like the light gets. So if you look at a light wave as being, they measure it as E equals HF, and some people put a slash divided by C squared. If you look at a light particle, it's having some energy, and energy and mass are interrelated. And the higher the frequency, the smaller the wavelength and more particle like it gets. Then at a certain frequency, it's going to turn into a particle. And that's really all it is. Rest mass is a frequency. That's why de Broglie gave us the equation E equals HF equals mc squared. Because when the frequency gets high enough, like you have the speed of light in the linear direction times the speed of light in the 90-degree angular direction. When the speed of light in the 90-degree angular direction reaches C, it balances out the speed of light in the linear direction, and it creates a balance of centrifugal forces and turns energy into mass with less mass. It's as simple as that. Now I came and I told a lot of people this story where and I put it in my first book And I wrote this book back in, published it back in 2004, Cosmic Alignment with the Cosmic Mind and the Cosmic Pattern. I was a little younger then. But anyway, it's in here. And at my book signing and reading, I told the people there the same idea, and they understood it immediately. And everybody I talked to seems to understand it immediately. It's not hard to figure out. And when I told the physicists this stuff, they just argued with me. Because, for one thing, they have a lot of money, time, and pride invested in their machine. They had to go to governments and get governments to give them the money to build this machine, and now they have to justify it. So they had to rally around a project. They chose the Higgs particle. They said to learn the origin of mass was very important. It would complete their standard model of particle physics. So they chose that, and after long enough time, they claimed that they failed the particle because they had to show something to show that they weren't just wasting money. Now, I don't like to step on those people's toes because we need these citizens to combat the things that the industrialists are doing to the environment, like creating global warming and earthquakes because of this fracking. So we don't need them to lose the credibility. But I had started working on this mass problem way before I even heard of the Higgs and their experiment because, as I saw it, it was just the uniting of quantum theory with general relativity, and that was the goal of Einstein, and that was to help to complete the picture of physics to unite quantum theory with general relativity, and they said it couldn't be done. But the problem was that they weren't looking at it geometrically. I took E equals mc squared and looked at it geometrically, which gave it everything fell into place. The geometrical interpretation of E equals mc squared is the same as the geometrical interpretation of quantum mechanics, h divided by 2 pi. And then you can go into h divided by 2 pi divided by 2 because that only just turns a circle into a sphere because it makes two rotations at right angles to complete one wave cycle, where h divided by 2 pi is just a circle. Now all of this, it comes about because of the square. See, in the linear direction times see in the 90-degree angular direction creates a 90-degree arc, which is constant creates a circle. The speed of light squared equals the speed of light circle. And that also equals g, one quantum of gravity rest mass. Now you have some people like our Nima Kini Kama. He's a famous professor. He says that the gravity constant would be way down there at 10 to the negative 35 meters, something they got from dimensional analysis, trying to equate the speed of light, Planck's constant, and the gravity constant. And they came up with things they call the Planck units. And one of the Planck units was a length, a Planck length, 10 to the negative 35 meters. And they say that that's where you will find gravity constant or not. For one thing, the dimensional analysis does not work down on the quantum level with the unity of the constant because they have a rule for dimensional analysis that says you can't equate light dimensions such as length, time, mass, energy, temp, stuff like that. Now it works on a larger scale, but not on a quantum scale. And E equals mc squared proved that the same way it proved that the law of conservation of mass by itself was wrong, and the law of conservation of energy by itself was wrong. Now you needed a law that says the law of the conservation of mass energy because they're the same thing. You know, it's the dimensional analysis doing all wrong. Quantum gravity, it is found right there in c squared, the speed of light squared. equals G equals H divided by 2 pi. All of them represent the same thing, the electron, the basic elementary particle. And that's the unity of general relativity and quantum mechanics and special relativity. They all flow into each other. But anyway, I'm going to be showing you some more stuff. The square root of -1. We found out that that's not just an imaginary number, that's a real number, a real natural unit. It equals C in the 90-degree angular direction counter to the trajectory of the particle. And it's the square root of the natural unit -1 charged electron. That's why it works so well in electronics. It's a real natural unit, no longer an imaginary number. We give G, the gravity constant, a real natural unit, which is C squared, and it proves that black holes are infinitely dense and small point particles, as well as big bangs of the same, don't exist. The dark energy and dark matter problem comes about because of that same miscalculation of dimensional analysis and the constant. And we show why the gravity, at the short end, the inverse square law does not diverge to infinity, creating these infinitely dense and small black holes. And on the long end, the strength of gravity does not diminish continually. It reaches a constant where everything does rotate, stop diminishing, and just rotate together. And that's why the galaxies rotate the way they do. And also the dark energy clouds that they see hovering around the galaxies. That's because space pushes in on matter, because matter pushes against space. As a matter of fact, that's how gravity emerges. The speed of light barrier is what energy compresses up against. If it can't go any further this way, it'll start going faster in this direction. It's like if you shine a light from a car, if you throw a rock from a car, neglected wind resistance, the rock may go further than if you do it on the ground, because you add the speed of the car to the speed of the rock. But if you show the flashlight from a car or its headlights, the speed of light wouldn't go no faster in this direction if the car was moving 100 miles an hour or if it was still. That's because the speed of light is constant in the linear direction, but it will go faster in the angular direction. The frequency will be higher with the higher speed. That's how radar works, because they can tell what speed the car is, because the motion of the car gets added to the speed of the frequency, not to the. It doesn't make it go any faster in this direction like a rocket, like it would a rocket. But it doesn't make the frequency go up. And the higher the frequency, the more particle-like the wave becomes. Then at some point, a wave becomes a particle. Now, we'll see that in more detail. And thanks for watching. Thanks for watching.